The National Electrical Code, or NEC, addresses the practice of bundling multiple multi-conductor, or MC cables. The NEC generally prohibits bundling MC cables together unless they are specifically designed and rated for that purpose. Article 334.70 of the NEC explicitly states that MC cables shall not be bundled together with other conductors. The primary reason for this restriction is the potential for electromagnetic induction, which can lead to excessive heat buildup and damage to the wires. When alternating current, or AC, flows through a cable, it generates a magnetic field. If multiple MC cables are bundled together, the magnetic field from one cable can induce an electric current in the nearby conductors of other cables. This induced current can cause the conductors to overheat, potentially leading to insulation failure, arcing, and even a fire hazard. It is important to understand that electrical codes are in place to ensure safety. The NEC does recognize some exceptions to the general prohibition against bundling MC cables. Firstly, MC cables that are specifically rated for bundling, such as MCB cables, are permitted to be bundled together. These cables are designed with features that mitigate the risk of overheating, such as improved insulation or a larger conductor size. Secondly, short lengths of MC cables, typically for a distance of 2 feet or less, may be bundled together to facilitate connections or routing through equipment. In these cases, the risk of overheating is reduced due to the limited length of the bundled section. However, if MC cables must be bundled together, the inspector may require additional measures to mitigate the risk of overheating. One option is to use thermal insulation to reduce heat transfer between the cables. Another option is to separate the cables with spaces or cable trays to promote airflow and dissipate heat. Additionally, it may be necessary to reduce the current load on the cables to further minimize the risk of overheating. When working with electrical systems, always prioritize safety and compliance with the NEC. Consulting with a qualified electrician is recommended for the proper installation and bundling of MC cables to ensure adherence to safety standards. Remember, electrical work can be dangerous, and improper installation can have serious consequences. The NEC guidelines are established to protect people and property from electrical hazards. Ignoring or circumventing these guidelines can result in fires, injuries, or even fatalities. It is also important to remember that electrical codes can vary depending on the location. Always consult with the local authorities or a qualified electrician to ensure compliance with the specific regulations in place. In addition to the NEC, there may be other local or state codes that apply to electrical installations. These codes may have additional requirements or restrictions that must be followed. Failure to comply with these codes can result in fines, penalties, or even legal action. Furthermore, it is important to understand that the NEC is not a substitute for proper training and experience. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills to do the job safely and correctly. Attempting to perform electrical work without proper training can be extremely dangerous and can lead to serious injury or death. When in doubt, always consult with a qualified electrician. They can provide expert advice and guidance on how to safely and effectively install and maintain electrical systems. They can also help ensure compliance with all applicable codes and regulations. Electrical safety is everyone's responsibility. By following the NEC guidelines and taking appropriate precautions, we can help prevent electrical accidents and protect people and property from harm. The NEC also provides guidance on the proper selection and use of electrical equipment. It specifies the types of equipment that are approved for use in different locations and under different conditions. It also provides information on the proper installation and maintenance of electrical equipment. Failure to use approved equipment or to install it properly can create a fire hazard or other safety risk. For example, using extension cords as a permanent wiring solution is a common code violation. Extension cords are intended for temporary use only and are not designed to handle the same amount of current as permanent wiring. Overloading an extension cord can cause it to overheat and start a fire. It is also important to protect electrical equipment from physical damage. Damaged equipment can create a shock hazard or other safety risk. For example, a cracked or broken electrical outlet can expose live wires, which can cause a serious shock if touched. Another important aspect of electrical safety is grounding. Grounding provides a path for electricity to flow safely back to the source in the event of a fault. This helps prevent electrical shocks and other hazards. The NEC requires that all electrical equipment be properly grounded. It also specifies the methods that must be used to ground electrical equipment. One common grounding method is to connect the equipment to a grounding electrode, such as a metal rod driven into the ground. The grounding electrode provides a low resistance path for electricity to flow back to the source. Another grounding method is to connect the equipment to the metal frame of the building. The metal frame of the building is typically grounded to the earth, providing a similar low resistance path for electricity to flow back to the source. It is important to ensure that all grounding connections are tight and secure. Loose or corroded connections can create a high resistance path, which can reduce the effectiveness of the grounding system. Regular inspections of the grounding system are recommended to ensure that it is in good working order. In addition to grounding, overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overload or short circuit occurs, the overcurrent protection device will trip, interrupting the flow of electricity and preventing damage to the circuit. The NEC specifies the size and type of overcurrent protection devices that must be used in different electrical circuits. It is important to use the correct overcurrent protection devices to ensure that the circuit is properly protected. Using the wrong overcurrent protection device can create a fire hazard or other safety risk. For example, using a circuit breaker that is too large for the circuit can allow the circuit to overload, which can cause the wires to overheat and start a fire. Regular inspections of overcurrent protection devices are recommended to ensure that they are in good working order. Circuit breakers should be tested periodically to ensure that they trip properly when an overload or short circuit occurs. Fuses should be replaced immediately after they blow. It is also important to keep electrical panels clean and free of obstructions. Electrical panels should be accessible at all times in case of an emergency. Do not store anything in front of or on top of an electrical panel. This can make it difficult to access the panel quickly in an emergency. Keep the area around the electrical panel well lit. This will make it easier to see the circuit breakers and other components in the panel. Label all circuit breakers clearly. This will help you quickly identify the correct circuit breaker to turn off in an emergency. If you are not comfortable working with electrical panels, contact a qualified electrician to inspect and maintain your electrical system. In addition to the NEC, there are other resources available to help you learn more about electrical safety. The Electrical Safety Foundation International, or ESFI, is a non-profit organization that provides educational resources on electrical safety. ESFI has a website with a variety of information on electrical safety topics, including safe electrical practices, common electrical hazards, and how to prevent electrical accidents. The National Fire Protection Association, or NFPA, is another organization that provides resources on electrical safety. NFPA publishes the National Electrical Code, which is the standard for safe electrical installations in the United States. NFPA also offers training courses and certifications for electricians and other electrical professionals. By taking the time to learn about electrical safety, you can help protect yourself and your family from electrical hazards. Remember, electrical safety is everyone's responsibility. The Arizona area, like other areas in the US, adheres to the National Electrical Code as a baseline but may have amendments. Therefore, consulting the local authority having jurisdiction, or OJ, is important.